Today's lesson, vector and parametric equations of a plane. So far we've been talking about equations of lines, either in our squared or in our cube plane or 3D. Now we talk about the equation of a plane, something you have never done before. So it's a first time for you. Good. So we want to go back to a discussion that we've had before. What do I need in order to fully generate all the points in a plane? What do I need? I need two things. I need two vectors in the plane. One vector like that, and let's say I'll put the other vector like that. If I place my two vectors like that, collinear, am I able to generate any other point in the plane? All these points, am I? Obviously, I'm not able, but, so that brings me back to the condition that these two vectors need to satisfy. They need to be non-collinear. So if one is like that, the other one looks like that. Good. So let's change the color of this one. Let's make it blue. Good, good. So now, what do I need to do to generate a certain point here? Well, what I need to do, I need to multiply my first vector by a certain scalar. I need to multiply my second vector by a certain scalar. This is what I did right now um, by making my two vectors longer. Now at the intersection of the two at the diagonal of this parallelogram, there you go, I got my point. So on and so forth, I can do that and I can get any point. So I'm going back to my original two vectors. There you go, those are my original vectors. So make them bigger and smaller, multiply them by a scalar, and you can generate any point. You can get to any point in the plane. We've had that conversation before. So how about I call this point, this vector A, and the blue one is B. So that's what I need. I need two collinear vectors, A and B. Good. Now let's place my plane in the Cartesian plane. So what did I say? I said I need two vectors, A and B. This is vector A, for example, and this is vector B. Those are my two vectors, vector A and vector B. And what I'm going to do, I'm going to make the second one this color. Good. So A is this one, and B is this one. So what I can do, I can multiply them by scalar to get all the points in the plane. So I can do something like that. To scalar, we use T, let's use S and T. So I can do S times A plus T times B. Okay, so this is exactly what I showed you here, multiplying by scalars. I can generate points in the plane, exactly what I did here, but by making my vector smaller or bigger and multiplying by negative, does something like that to the vector. Good. So now, what is the problem? The problem is that doing something like that, I can generate indeed points. I can generate, I want to group this. So let's put this way. I'm going to generate the points in a plane, but this plane can move like that. It can be anywhere parallel to itself in my Cartesian plane. Can be anywhere. And I can still generate, doing something like that, I can still generate all the points in that plane. So what I need a certain point, a fixed point, P0, that is P0 of coordinates x0, y0 that is part that is on the plane. So I need another point P0 on the plane. I do not talk points, I talk position vector. So let's construct the corresponding position vector. There you go. That position vector takes me to that specific plane. So there you go. This is what I have now. How do I construct a certain point over here, somewhere over here, for example? Well, exactly what I did before. I will make my A and B bigger or smaller, multiplying by scalar. I'll do the diagonal of the two vectors, and then to get from this to get to that point, what I need this position vector. Okay, so basically, what did I do there? I said, oh, multiply A by a scalar, B by a scalar. In my case, it was 1 and 1, and then add it to the position vector R0. R0 is defined as x0, y0. So that point makes sure I do not talk about all the parallel planes there. So let's write R0 plus SA plus TB, and this is nothing else but vector R, the position vector, the green one here on my diagram. Guess what I got here? I got the vector equation of a plane. Vector equation of a plane. Good. Guess how I'm going to get the parametric equations. R on components is x, y, z, R0, x0, y0, z0, plus A is A1, A2, A3, the three components, plus P, B1, B2, B3. So I can write my three parametric equations of a plane. X equals x0 plus SA1 plus P1. Absolutely similarly, y equals y0 plus SA2 plus PB2, and z equals z0 plus SA3 plus PB3, where S and P are, of course, real numbers. They help me create a parallelogram in my plane. There you go. That's a lesson for today.